The mission began with a warning nobody expected to hear. Silence filled the control room as engineers stared at blinking screens. Something was wrong, but no one could explain it immediately. The spacecraft drifted slightly off course, barely noticeable at first. A routine mission was suddenly becoming something far more dangerous. Astronauts aboard remained calm, unaware of the growing concern below. Back on Earth, calculations started showing unusual and worrying patterns. The trajectory data did not match any expected flight path. One small error had quietly slipped through multiple safety checks. That tiny mistake was now threatening the entire mission's success. Engineers quickly gathered, reviewing every detail with intense focus. Time was limited, and every second increased the potential risk. The spacecraft continued forward, unaware of the invisible danger ahead. Inside, the crew followed their schedule with disciplined precision. Outside, space remained vast, silent, and unforgiving as always. The first alarm triggered softly, almost easy to ignore initially. A technician noticed it and immediately alerted the mission director. Tension rose as more indicators began flashing across multiple screens. This was no longer a minor glitch or simple miscalculation. Something deeper was affecting the spacecraft's navigation system stability. The team needed answers, and they needed them very quickly. Every system was checked again, line by line, without pause. The clock kept ticking, adding pressure to every decision made. A small misalignment in thrusters became the leading suspect issue. If left unchecked, it could worsen and push them dangerously off course. Communication with the crew remained steady, but concern was growing. The astronauts sensed tension but stayed focused on their duties. Training prepared them for emergencies, but this felt different somehow. Ground control debated whether to inform the crew immediately. Panic could be dangerous, but silence carried its own risks. Finally, they decided to share limited information with the astronauts. The message was calm, but its meaning was deeply serious. The crew acknowledged and prepared for possible corrective actions ahead. Their calm response helped stabilize the situation emotionally for everyone. Still, the technical problem remained unsolved and increasingly urgent. Engineers proposed several solutions, each carrying different levels of risk. Some options required manual intervention from the astronauts themselves. Others depended on remote adjustments from mission control systems. Choosing the wrong solution could make the situation far worse. The mission director weighed every possibility with extreme caution. Experience guided decisions, but uncertainty still lingered heavily. A senior engineer suggested recalibrating the navigation system mid-flight. It was risky, but it offered the best chance of recovery. The plan required perfect timing and flawless execution by everyone involved. One mistake could lead to complete mission failure or worse. The astronauts received detailed instructions and began preparing immediately. Every movement was calculated, every action double-checked carefully. Meanwhile, ground control monitored every signal and system closely. The spacecraft entered a critical phase where precision was everything. The margin for error had become dangerously thin at this point. The recalibration process began, and all eyes were fixed on data. Initial readings showed slight improvement, giving hope to the team. However, unexpected fluctuations soon appeared, raising fresh concerns quickly. The system was reacting unpredictably, complicating the entire correction process. Engineers scrambled to understand the sudden changes in behavior. The astronauts maintained focus, awaiting further instructions from Earth. Communication delays made coordination even more challenging than usual. Every command took time, increasing tension during critical operations. The mission stood at a fragile turning point between success and failure. One final adjustment was proposed as the last viable solution. It required courage, precision, and complete trust between crew and control. The decision had to be made quickly before conditions worsened further. The room fell silent as the mission director prepared to respond. All calculations pointed toward a narrow window of opportunity remaining. The next move would determine the fate of the entire mission. Ground Control carefully reviewed data before authorizing the next mission step. Engineers analyzed every system to ensure the spacecraft remained fully stable. Astronauts received updated instructions for the carefully planned corrections ahead. Their training helped them act calmly and efficiently under pressure. The spacecraft continued its journey while adjustments were prepared meticulously. One astronaut initiated the first correction sequence as instructed precisely. Another monitored the instruments closely, checking for any unexpected changes. The team synchronized actions to make adjustments perfectly and safely. Every second counted as the spacecraft moved through space steadily. The first adjustment completed, and system readings showed minor improvement. Engineers examined incoming data to confirm responses matched expectations. The spacecraft slowly corrected its path, reducing trajectory deviations slightly. Minor vibrations appeared, but stayed within safe and manageable levels. Ground Control communicated clearly with the astronauts to ensure coordination. A second adjustment phase was carefully prepared with added precision. This step involved slightly stronger corrections to refine the trajectory further. Astronauts followed each instruction methodically, maintaining calm and focus. Clear communication prevented confusion during this critical operation phase. Data screens updated constantly, showing progress in real time. Engineers evaluated each response, adjusting plans based on accurate readings. The system responded gradually, bringing the spacecraft closer to its path. Confidence grew cautiously as improvements became more noticeable on instruments. Still, the team remained vigilant, monitoring every system closely. A minor fluctuation appeared, prompting careful review by engineers immediately. Astronauts confirmed all controls were functioning and safe on board. Ground Control proposed slight parameter adjustments to optimize trajectory alignment. Astronauts executed adjustments carefully, maintaining full precision in every step. The spacecraft showed steady improvements, confirming initial corrective efforts worked. Energy consumption stabilized, reducing previous operational concerns significantly. Trajectory alignment continued improving gradually as corrections progressed. Engineers double-checked calculations to ensure future stability throughout the mission. The team coordinated to prepare for the next final adjustment phase. All departments confirmed readiness, ensuring safety before the critical step. Astronauts prepared controls for the most precise correction yet. Communication remained clear and calm between Earth and the spacecraft. The final adjustment was carefully initiated with full attention from all. Data showed strong system response, indicating successful trajectory improvements. The spacecraft gradually aligned closer to its intended path. Engineers confirmed stability while monitoring small deviations continuously. Minor fluctuations were noted but stayed safely within acceptable limits. The astronauts executed each command accurately and without delay. Ground Control verified responses in real time, ensuring every system functioned. The spacecraft moved steadily, showing noticeable correction progress. Confidence increased as critical systems responded consistently and safely. The mission director allowed cautious optimism while monitoring remaining risk. Astronauts maintained focus, ready to handle any unexpected changes. Engineers adjusted monitoring tools to detect even the smallest anomalies. Every adjustment brought the spacecraft closer to full stability. Teamwork ensured corrections were precise and operations remained safe. The trajectory improved gradually, aligning more accurately with mission plans. Data analysis confirmed each correction was effective and reliable. The control room felt relief, but focus remained on safe completion. The astronauts performed verification sequences to confirm systems were stable. Ground Control tracked every signal to ensure no further deviations occurred. Minor system noise appeared, but did not affect overall operations. The spacecraft continued forward safely, approaching the corrected trajectory fully. Engineers documented every adjustment for future mission learning and improvements. Astronauts maintained calm efficiency, completing all necessary checks confidently. Team coordination demonstrated how preparation prevents small issues from escalating. The mission moved steadily toward a fully controlled and safe state. Each passing minute confirmed the spacecraft's trajectory was secure. Communication between crew and Earth remained uninterrupted and effective. Adjustments were verified multiple times to ensure long-term stability. The near-miss situation became a valuable lesson for all involved. With this phase complete, the mission now approached safe and stable conditions. The mission team now focused on understanding the root of the issue. Every piece of data was carefully reviewed for hidden inconsistencies. Engineers revisited earlier calculations to trace the original mistake. The smallest detail now carried significant importance for future safety. A pattern slowly began forming within the analyzed system logs. It pointed toward a minor calibration drift during early launch stages. This drift went unnoticed due to overlapping automated corrections initially. Over time, the effect increased and pushed the system off balance. The discovery brought clarity, but also raised serious concerns. Even advanced systems could allow small errors to grow unexpectedly. The team documented everything to prevent similar issues later. New verification steps were proposed for upcoming missions immediately. The astronauts listened as the findings were shared with them. They understood how close the mission came to serious disruption. Still, their focus remained on completing the journey successfully. Ground control updated all procedures based on the recent experience. Extra monitoring layers were added to critical navigation systems. These changes aimed to detect even the smallest irregularities early. The spacecraft continued forward with stable and reliable performance. Confidence in the system slowly rebuilt after the successful recovery. The mission timeline adjusted smoothly to align with current conditions. Every step ahead was now taken with increased awareness and precision. The team remained alert, though the situation had improved greatly. Communication between crew and control stayed clear and consistent. Regular updates ensured everyone remained informed and prepared. The astronauts carried out their duties with renewed focus and discipline. Their experience added valuable insight into real-time problem handling. Back on Earth, analysts continued reviewing performance metrics carefully. Each system was evaluated under different simulated conditions again. The results showed stronger resilience after the adjustments were applied. The mission began regaining its original rhythm and momentum. What once felt uncertain now seemed controlled and manageable. The earlier tension slowly transformed into confidence and determination. Engineers discussed improvements for future spacecraft design strategies. Small enhancements could make a major difference in long missions. The experience emphasized the importance of constant system monitoring. It also highlighted the value of teamwork under pressure. The astronauts shared feedback to improve onboard response procedures. Their insights helped refine communication and decision-making processes. The mission director reviewed all suggestions with careful consideration. Plans were made to integrate these lessons into future training programs. The spacecraft remained steady, moving precisely along its path. No further irregularities were detected in navigation or control systems. This stability confirmed the success of earlier corrective actions. The mission team maintained discipline despite the improved conditions. Success required continued attention, not just recovery from danger. The journey through space continued with renewed confidence. Every system operated within safe and expected performance ranges. The earlier issue became a valuable learning moment for everyone. It reminded the team that preparation must always match uncertainty. The astronauts remained ready for any unexpected situation ahead. Ground control kept monitoring, ensuring continuous support at all times. Together, they formed a system stronger than any single failure. The mission progressed steadily toward its next important milestone. Each passing moment confirmed that stability had truly returned. The sense of risk had faded, replaced by careful optimism. Still, no one forgot how quickly things had changed before. That memory helped maintain focus and responsibility throughout the mission. The spacecraft moved forward, guided by precision and teamwork. The challenge had strengthened both systems and human coordination. What seemed like failure became a turning point for improvement. The mission now carried lessons that would shape future exploration. Confidence grew stronger with every successful system check completed. The journey continued, now defined by resilience and careful progress. One final phase remained before the mission could be called complete. The countdown continued as the team prepared for the final adjustment. Every system was aligned carefully for a precise and controlled response. The astronauts confirmed readiness before initiating the critical sequence. Ground control monitored quietly, watching every signal with full attention. The command was executed, and the system responded almost immediately. A controlled correction gently adjusted the spacecraft's direction in space. Data streams updated quickly, reflecting noticeable improvement across systems. The trajectory line slowly returned toward its intended path again. A sense of relief spread, though caution remained extremely important. Engineers reviewed incoming data to confirm stable and accurate performance. The astronauts reported smoother movement and improved system behavior. Vibrations reduced significantly, indicating better internal system balance. The earlier risk began fading as stability returned step by step. Still, the team avoided celebration, staying focused on verification tasks. A detailed system check began to confirm long-term reliability. Each onboard system was tested under controlled operational conditions. Communication signals remained clear, supporting smooth coordination between teams. The navigation system displayed consistent and predictable behavior now. Engineers compared real-time data with expected simulation outcomes carefully. The alignment matched closely, strengthening confidence in the correction process. The mission director acknowledged progress but advised continued caution. The control room atmosphere eased slightly, though attention stayed sharp. The astronauts continued duties with discipline and careful observation. Their training ensured every action remained precise and controlled. A minor irregular signal appeared, prompting immediate review by engineers. The issue was small and manageable, requiring only slight adjustment. Ground control provided updated instructions for fine-tuning system settings. The astronauts followed guidance, making careful adjustments step by step. System performance improved further, reaching more stable conditions quickly. Energy levels returned to expected ranges, reducing earlier concerns. The spacecraft maintained a steady path aligned with mission objectives. Confidence increased gradually as consistent results continued to appear. The mission moved from recovery into a stable operational phase. Engineers documented all events to improve future mission planning. This situation offered valuable lessons for system monitoring and response. The astronauts shared brief updates, reflecting calm and controlled communication. Their teamwork played a key role in achieving successful stabilization. Ground control prepared a status update describing current mission progress. The message remained clear, focusing on stability and forward movement. Public updates avoided unnecessary concern while remaining accurate and responsible. Inside the control room, normal operations slowly resumed again. The mission timeline was adjusted slightly to maintain overall goals. New calculations confirmed that objectives were still achievable. The spacecraft continued forward, now moving smoothly through space. The earlier uncertainty was replaced with careful confidence and awareness. Still, the team remained alert for any unexpected system behavior. Space remained unpredictable, requiring constant attention and readiness. Even small variations were now monitored more closely than before. A final system review confirmed consistent performance across all modules. Results showed strong stability, meeting all required safety standards. The mission director allowed a moment of quiet acknowledgement. The team recognized the effort without losing focus on responsibilities. The astronauts received confirmation of successful stabilization from Earth. They responded calmly, continuing their work without distraction. The experience reinforced the importance of preparation and teamwork. Every individual played a role in preventing a larger problem. The mission now stood on a solid and controlled path forward. The earlier challenge became a valuable moment of learning. It strengthened confidence in both human skill and system design. The spacecraft advanced steadily, maintaining perfect directional alignment. The danger had passed, but its lessons remained deeply important. The team committed to applying these lessons in future missions. The journey continued, supported by stronger systems and coordination. What nearly failed became an example of careful problem-solving. The mission moved forward, preparing for its final phase ahead. The mission entered its final phase, with systems stable and reliable. The spacecraft moved steadily, following its corrected path with precision. Every team member remained focused on completing the mission successfully. The astronauts prepared for the final sequence of planned operations. Ground control reviewed all data before giving clearance to proceed. Each system check confirmed consistent and safe performance levels. The earlier issue now felt distant, but lessons stayed fresh. Communication between space and Earth remained clear and uninterrupted. The mission director approved the next step after careful evaluation. The astronauts initiated the final operation exactly as instructed. Every action followed a carefully planned and tested procedure. The spacecraft responded smoothly, showing strong system coordination. Data streams confirmed everything was functioning within expected limits. A sense of quiet confidence spread across the control room. Engineers continued monitoring, ensuring stability until the very end. The spacecraft reached its target position with accurate alignment. All mission objectives were now within reach of completion. The astronauts performed their final checks with full concentration. Each step brought them closer to a successful mission conclusion. Ground control prepared the final confirmation sequence carefully. The team reviewed every detail before giving the closing signal. The final command was sent, marking the mission's last operation. The spacecraft executed it perfectly without any unexpected response. Data confirmed success across all primary mission parameters. A wave of relief and satisfaction filled the control room. The mission that nearly failed had now fully succeeded. Applause broke out as the team acknowledged their shared achievement. The astronauts received the success message with calm satisfaction. Their discipline and teamwork made a critical difference throughout. The mission director thanked every member for their dedication and focus. Engineers documented final results for future mission improvements. Every detail would help strengthen systems for upcoming space journeys. The experience became a powerful lesson in precision and teamwork. It showed how small issues can grow without careful monitoring. It also proved that challenges can be overcome with coordination. The spacecraft began its next journey phase with stable systems. The astronauts reflected briefly on the intense moments they faced. Their training and trust helped guide them through uncertainty. Ground control finalized reports summarizing the entire mission experience. The mission would be studied for years as a learning example. Improvements would be applied to make future missions even safer. The team's effort turned a risky situation into a success story. The mission's success inspired confidence in future space exploration efforts. Every challenge faced had strengthened both people and technology. The spacecraft continued forward, now part of a greater journey. The earlier danger became a reminder of space's unpredictability. It encouraged continuous improvement and constant awareness moving forward. The astronauts resumed normal duties as the mission stabilized completely. Ground control reduced emergency monitoring and returned to routine operations. The atmosphere shifted from tension to pride and achievement. The mission stood as proof of careful planning and quick thinking. Every second of effort contributed to the final successful outcome. The team remained humble. Knowing challenges can appear at any time, they stayed committed to maintaining high standards in every mission. The spacecraft moved steadily, guided by precision and human effort. The story of this mission would inspire future explorers. It showed that even near failure can lead to success. Determination and teamwork turned risk into achievement. The mission officially concluded with full success confirmation. Every objective was completed safely and accurately as planned. The control room slowly returned to normal operations once again. The astronauts prepared for the next chapter of their journey. The mission that almost failed became a story of resilience. It reminded everyone that challenges can be overcome with focus. And in space, every success begins with facing the unknown bravely.